Yeah. Um, Hello. Let's see how to solve this problem. Lead code number 200, number of islands. So let's see the question. So we are given an n by n matrix which contains ones and zeros. Ones means land and zeros means water. And we need to return the number of islands. So what do they mean by island here is the group of ones which are connected in horizontal or vertical direction. Here you can see these four. These four combine to form an island, and this single one form an island. And these two will form an island. So we need to return the number of islands. Let's see how can we solve this. Uh, see, let's think of an approach. How can we approach this question? Here you can see if I found any one, I need to see. I need to mark all of its neighboring nodes which are ones. If I'll retrieve from start to end, like first node to last node. I will come here. It is one. I will go and mark all of its neighboring nodes. This one, this one, this one. They are done. So my answer count will increase to 1. I'll come here 0, 0, 0, 1 visited already, 1 visited already, 0, 0, 0, 0, 0, 1. I'll again mark this node and its neighboring nodes. Count will be increased to 2. This will be marked as visited 0, 0, 0, 0. Come here. This is not visited and it is 1. So and I will visit all of its neighboring nodes and mark them as visited. Count will be increased to 3 and I will return 3. Let's see how can we solve this. M rows, columns. Okay. And the visited, boolean visited, new boolean of M rows and columns. Current by 0 I less than current J007 J plus plus number of islands with the 0. So if any node is 1, instead of ij equal to 1 and it is not visited, visited of ij not visited, what I will do, I'll apply BFS there and I'll increase count number of islands plus plus, and at the end I return this number of islands. Okay, so now the question is, how can I apply this DFS to make sure I'll visit all of its neighboring nodes, like directions up, down, left, right. I need to check in all the four directions. If there are any ones, I should mark them as visited. They'll come under the same island. How can I do this? Let's see. DFS in my current node. It's not exactly current node, it's my node, and I need to send what I need to send. Let's see here. Hmm, it's a current ing row and column and the visited array to mark them as visited. Grid to check its values whether it is 0 or 1, and we can send m and n also. They will be helpful. Okay, or else we can calculate them using grid. That is also fine. Int r and c. Okay, boolean array visited int r int r. Hmm. So how can we check in four direction? That's the question. So I'll tell you. So assume where I tried here R and C. So if we want to go to up, what will its values? Let's left first. If I want to go left, what will be the values? So it will be same row but column will be minus 1. Okay, R C minus 1. If you want to go right side, same row, but column will be +1. Okay. So if you want to go left and right, the column will changes. So similarly, if I want to go top or bottom, the row will changes. If I want to go up, same column, but row will be decreased. If I want to go down, next row, but same column. Okay. I'll use these things. I'll declare them here. So if you observe, row changes from -1, 0, +1, 0. Delta row, -1, 0, 1, 0. Okay. So when row has these values, when row is -1, column is changing by 0. When row is 0, column is changing +1. 0, 1, 0, -1. The column 0, -1. Okay. So if we need to apply DFS, we need a queue data structure. I need to store row and column. So let's define a class pair to store row and column. Equal to column. Okay. Just queue pair. Queue. Link the list of. I just need normal queue. And right now I'm in this node. I need to make it as visited. Okay. I'll add this to my queue. Pair of RC. So and I'll iterate till queue is empty. So let's check our code with this example. This example 2, so that you'll be able to understand this easily. So right now I'm at here. Okay, I added this one to queue 0, 0. Then I'll check in all the 4 direction and I'll see if there is any 1 and it is not visited. I'll add it. Pair current. Okay. Um, current row will be current row. Current column will be current column. Okay. I'll check in 4 directions. How I'll do it? 0 to so I plus plus. Okay. So my new row will be current row plus delta row of I. The column will be current column plus delta column of. Okay. Now I need to check if the new row and new column are valid or not. It should be greater than or equal to 0. It should be less than m, which is the max number of rows. And column should be greater than or equal to 0. Column should be less than or equal to less than n, and it should be 1. Okay. So I need to write it here. And it should be 1. Okay. Without new row, new column, it should be 1. And it should not be visited earlier. I must be visiting it first time. Not visited of my new row, new column. Okay. If it satisfies all this condition, then I found a new neighboring node 1 which is not visited. So in our case, it will be this one and this one. Okay. This is my current node. These two are my neighbor nodes. Okay. I'll add them to queue. Without add of new pair of new row, new column. And I'll mark them as listed of new row, new column equal to 2. Okay. So then my queue will come. I have removed this. and I added these two nodes, and I mark them as visited. From these two, I reach here. So since this is the neighboring node, so all these four are visited, and I mark these four as ones. I visited as two, so there are no other nodes. So BFS will be completed. Number of islands will be one, and I'll continue again. Right now I'm at this node. Okay, I'll check this and I'll done the BFS. If I come here, it is 1, but it is visited, so I'll not do BFS. It is 0, I'll not do BFS. 0, no BFS, no BFS. 1, but it is visited, no BFS. 1, but visited, no BFS. So till here, there will be no BFS again. So here I will apply BFS again, and it will be number of islands will be incremented by 1. Okay, and again for these two, I'll apply again BFS, number of islands will be incremented by 1. Okay. Uh, let's see. Okay. Oh, it got accepted. Now let's analyze time and space composition. Okay. Time. So in this function, I can see I have two for loops, m rows and n columns, which is m into n. So here it seems like we are running this PFS for all the m into n times, but it is not. We are running only for some number of times. Okay. The worst possible case can be all are ones. Okay. If all are ones, I'll run BFS one time. Okay. But for every node, I'll check 4 directions. BFS will be done for every node. I mean, for BFS will be done one time, but this will be checked for all the nodes. Since everything is one, if I go to any node, I'll check in all the 4 directions. This is my time, space. Okay, space visited, I'm into n. And in BFS, I'm using a queue to store the row column value pair. So at max, I'll store these many pairs. Okay, at max is the first possible case. So this is the time and this is space. So yeah, that's it. Yeah, thank you.